All right, well, welcome to my general chemistry class here at Texas Tech. I'm very excited to hear you're going to be a student with me this semester. Here at the onset of the semester, I wanted to talk to you a little bit about the general chemistry class and some things that you could do to really improve your performance. I want to do this at the onset to try to help you along the way as much as possible, to give you some advice, things that I've learned over the years of teaching that can maximize your ability to do as good as possible. Okay, so a couple things. This general chemistry bit, it has a reputation of being a pretty challenging class. Oftentimes 30 to 40% of students who begin the class do not complete it successfully, and this is actually true at Texas Tech and many other universities as well. So you're very much in good company if you do struggle. There's a number of different reasons for that, and we'll talk about some of those from my perceptions here in the rest of this video, okay? But I do want you to know that this is a challenging class. It's very common that we might have an exam average between 50, 60, 70%. And even though the exams are all multiple choice, it turns out that tends to be about what the average has been historically. Now, as an instructor, am I happy with that, or are students happy with that? Absolutely not, right? We want to do as good as we possibly can on all fronts. But that is just kind of a historical average. Maybe you can expect that. Now, can we do better? Perhaps we can. And again, this video, I think, will provide a framework for how you can maximize your performance in a difficult class such as general chemistry. Now, to sort of frame the rest of the video, I believe, in my experience, one of the major reasons why students will struggle is what I'm referring to here as a general malfunctioning of the learning cycle. It turns out human learning is really cyclical, and I'll present that information here later in the video. But if that cycle becomes short-circuited, so to speak, it really malfunctions and it breaks down. And that's where we fall into a lot of problems. So I'm going to go through that cycle, explain it as I understand it. Hopefully you'll get something out of that. And what I'd like you to do is be very intentional for the rest of the semester, trying to make sure that you're following the steps of this cycle for each and every, day of the class, each and every chapter. Follow the steps of this cycle. And I think it's going to really pay off for you if you do, okay? So that's going to be my advice for doing well. A bit about grading and grade concerns. I do want to see everybody in the class excel. It would be wonderful if everyone could score above a 90%, and I can give everyone an A at the end of the semester. That would be like the greatest result ever. Okay, it's frustrating when students do not do well. Obviously, the students are frustrated. The instructors are equally frustrated. So understand that that's the case. We like to see everyone excel. But with that said, I kind of have a job to do, and my role as your professor this semester is to deliver lecture content, and that's going to be with the goal of having you develop rapidly mental models of how chemistry works. I'm going to give you some opportunities to allow you to test those mental models. This is going to be through homework or in-class polling. And then I'm going to evaluate your mastery of the topics through giving you exams and assigning grades, ultimately, okay? That's typically done at the end of the semester. And the exams are throughout the semester, right? In the evenings, typically. Now, things that I find are a little bit of a time waste with regards to grading. A big one is students often email me and want to have meetings to talk about your quantitative grades in the course. And it turns out these meetings are pretty ineffective, and that's because grading is standardized across all sections of the course here at Texas Tech. There's no flexibility in that. There's no extra credit for one student or one section. There's no changes in grade weighting for one student or one section. There's no opportunity for that at all. So unfortunately, your only hope is just to improve your scores on the homework assignments and the exams. And this video really serves to give you some of the advice that I would give at such a meeting for how you can do better, okay? So I hope that you get something out of it from that perspective. Also, things that tend to be kind of a bit of a time waste. Students will sometimes want to tell me all about how they're doing in their physics or high school chemistry class and that they did so great in that, and want me to know how well their TA is scoring their lab reports. And It's really good that you're doing well in those courses, but unfortunately, those assignments are different than the ones that you face in this class. The expectations may be different, and because of that, they're somewhat irrelevant to the class. So I'm real happy to hear that those things are going well, but at the same time, you can't expect quantitative grading credit for them as it relates to this lecture. All right, well, let's dive into this then, this business of strategies to increase your performance in general chemistry. The first thing I want you to know is I can't provide a simple checklist that will assure your success, but I can give you some advice. And this advice ultimately is rooted in research that's recently been conducted that studies how humans learn, essentially, okay? So let's begin by discussing what we know about how humans learn, and then we'll build from that sort of a theoretical bit of constructs into some things that are more practical that you can do. And that really, these practical things really link back to the theory, so it's kind of a nice story. So recent research in learning has uncovered that there are different domains, okay? There are really three different domains. There's the cognitive domain, the affective domain, and the psychomotor domain. Now, the cognitive domain, this is all about knowledge and thinking. I think you're the most familiar with this one, and oftentimes lecture courses will test you on this, your knowledge, what you have memorized, or your ability to think about something, okay? But there are other domains as well, which are also very important in learning. The next one that you're probably next most familiar with is psychomotor. Psychomotor, I like to call that the doing domain. This is where you take knowledge that you've acquired and you do something with it. A great example of this is the lab class for general chemistry. In the lab, typically what you do is show up at a predetermined time and you perform an experiment. And that experiment is carefully chosen to match one of the topics that you're learning about in lecture. And the hope is that by performing that experiment, maybe you use some of the skills you learned in lecture or some of the models that you built, and maybe you use that experimental data to reinforce that knowledge, okay? So this cognitive and psychomotor domains, they kind of interact, so to speak, in the lab class. And that's why we often make the lab class a co-requisite for general chemistry. You take the two, lecture and the lab together. But there is a third domain. And this third domain is called the affective domain. It's the one here in the middle. This one doesn't get a whole lot of respect, and many times people even completely don't acknowledge that this exists. It's just kind of a recent development that the importance of this affective domain has been uncovered. And I want to talk a little bit about this because this is actually where we're going to start in terms of setting goals for improving our performance once we get to the next slide. But what this affective domain is it's essentially the feeling or the emotional or experiential domain. It's a very human domain. It's what you think or feel about a subject or a topic, how you value it. It's a very human thing, okay? It's very different than just thinking about the content. And it turns out that this affective domain can be very important in your success ultimately. It's not the only thing that's going to affect your success, but it's one of the things. We're going to actually start there. All right, so it turns out that our brains are really amazing organs, okay? Really, really amazing. You may not realize this, but it turns out about a third of your calories that you intake every day are used by your brain for various different processes. Maybe some of that's thought, but most of it is just keeping your biological systems functioning properly. For instance, a signal goes to your heart to keep it beating or to keep breathing. And of course, our brains have developed to the point that these systems function without us even thinking about it. It's just autonomous, essentially. We don't have to have any thought or action to keep our heart breathing, or heart beating, or ourselves breathing, because that's crucial to our organism's success, right? That makes a lot of sense. We don't have to think about it, okay? Lord, it would be horrible if we forgot, right? The thing is that if we use our brains for thought or cognition, get into this cognitive element up here on the top, the brain has to make the decision that that's of value to us. just like breathing is of value to the organism. Now, that's done automatically, but for thoughts, it's not necessarily always done in an automatic fashion. Think about it. How many times have you just walked down the street between classes, or walked between classes? Hundreds of people may pass you, but if I was to ask you what color shirt was the last person wearing that passed you on the street, you probably wouldn't even have noticed that, and you wouldn't have thought about it, okay? Unless it was a particularly nice shirt or something. The guy was handsome or the lady good looking, something like that, right? And that's because we're constantly bombarded with stimuli, most of which is unimportant to us. And our brain very, very quickly filters the information that we see to sort out into unimportant and important. And it really only pays attention and forms thoughts out of things that we deem valuable or important. This is really, really important for learning. People are finding more and more that this is crucial, that your brain needs to make that decision that this information is important so that it can file it and organize it appropriately. That is an action of the affective domain, what we think or feel or how we perceive the information. It's all that affective domain. So one thing I need you to do here at the onset of the class, if we're going to do well, is I want you to invest a little bit of time into thinking about why you should value the topic of chemistry. Why should you value learning it? And this might be a very broad goal. Like, for instance, maybe you have a dream of graduating university and getting a research degree and going on and curing cancer or coming up with a new vaccine for a particular condition, okay? Maybe that's what you want to do. And chemistry, you need to know about chemistry to be able to do that, okay? So chemistry is of value to you, and your brain will perceive it as such. Maybe you're just interested in the theory of chemistry or how things work from a kind of fundamental physics perspective. And maybe your brain will assign value to that. And that can get you into this cognitive domain. But the crucial element is that we need to have a valuation placed on the information that we learn to get through the gate into the cognitive domain. So you are essentially the gatekeeper for your brain. You have to value the material that you're being taught. So what I need you to always do, okay, whether it's chapter by chapter, topic by topic, or just these broad overarching goals, come up with a reason to value studying the chemistry. Value making progress in the course, okay? Oftentimes when you hear these inspirational quotes, that you might hang on the wall or something to inspire people, it might say something along the lines of dream and then do, right? But dream usually always comes first. And that's very consistent with the thinking of this affective domain. You have to come up with that valuation first before you're really motivated to do anything about it, okay? So that's really goal number one. Come up with a valuation. After you do that, you're going to be receptive to receiving the information that I present in lecture. You're going to be receptive to responding to that information. Your brain is going to start to organize it and make sense of it and characterize it and file it in different places. And all that's going to start to occur very quickly internally in your brain, almost with no effort, as it turns out, just because you've kind of made that decision to value the topic, okay? Now, after we get through this gate into the cognitive domain, that's where we start to think about things. We start forming thoughts. Maybe in some cases we memorize things, right? We know them, we understand them, and we're able to make judgments based upon our understanding in the cognitive domain. The cognitive domain interacts with the psychomotor domain as well, okay? Because down here in the psychomotor domain, in the bottom, I like to think that remember that was the domain of actually doing something, right? Hands-on type work, right? That the psychomotor domain is where we take the information that we've learned in the cognitive domain, our understanding of a topic, and then we actually go and we do something with it. So the psychomotor domain is the domain of human creation or projection. And ultimately, this is what we want to do in our careers after you graduate, right? You don't want to just learn about chemistry. You might want to take what you learn and apply it somewhere. Maybe you make a new pharmaceutical, or again, a new vaccine, or cure cancer, whatever it is. You're doing something. You're creating new knowledge that's rooted in your own previous experience and your own uniqueness. Okay, and I think we all have a human drive to want to create new knowledge. So as a result, I think the psychomotor domain really is also a bit of a reward domain. It's kind of intrinsic rewards, having a meaning in what you're doing. A lot of people say that they want to do work that has a meaning or a purpose, right? And I think that's kind of what's going on here in the psychomotor domain. So in the end, we've got these three domains that really interact with one another, right? Because we value something enough to think about it and study it and form thoughts in this cognition domain. And then we use that information to actually create new knowledge that provides a reward that we feel good about. Again, to get back to this affective domain where we're valuing what we're doing, and this cycle kind of completes itself, so to speak, and really iterates through many times over a lifetime. But the key to all this is starting the cycle, and that's really to make a decision that you value this topic enough to invest the time in it that's necessary to get up in here and to master the content. All right, so now once we value the information enough to exert cognitive effort on it, where do we go from there, right? So let's talk about a sub-cycle, a cognitive cycle, if you will. Sometimes this is referred to as the learning cycle, and you may hear me do that throughout the discussion of this slide. How's this going to work, right? And this really needs to be your model for how you learn in this class, how you study in this class, okay? So I'm going to spend some time going through this, talking about it from sort of a theoretical perspective, and then giving you some practical tools or practical things that you can do that's consistent with this model, okay? And the first thing I want you to know is that this cognition cycle starts here in the middle, where it says students construct a mental model of a topic. If you're going to learn something, what you need to first do is create a mental model of how that works. Now, if it's in the case of an atom, you need to start by thinking about how an atom is organized, how it's put together, what parts are there to an atom, right? And you take that information and you build a model in your mind of how an atom works. Now, that process of building a mental model within the student's mind is very important for learning, but it's not the only thing that needs to be done, as we'll find. There are additional steps. But for a second, let's just talk about how those mental models are going to be built, or how they're usually built. One of the ways that a mental model is going to be built is through a student's previous experiences. This is the third one listed on the left. All of your previous experiences are going to go into building your mental models. Maybe you've seen chemical reactions before. You kind of have a feel for how they might work based on that experience. That's going to be important for building your particular mental model in your head, okay? Now, that's not the only way that we can build our mental models. There are a couple other ways. The first one on the left is the lecture-based instruction. The lecture-based instruction is going to be one of the primary ways that our students are meant to build mental models for the topics that we're going to consider in this course. Think about it. Go into lecture, a 50-minute lecture on Monday, Wednesday, and Friday. During that lecture, during that short time period, 50 minutes, your instructor may present material that required hundreds of years of scientific research to establish as factual. So by going to that one 50-minute lecture, you're really getting a tremendous amount of information given to you to build your mental model of how this particular topic works. And this is why going to lecture is absolutely crucial to success in the class, because it's a highly efficient way of building your mental model, which is the first step in our cognitive cycle. That's what lecture is all about, is giving you that mental model in a very quick, efficient way. Everybody wants to be efficient and make the best use of their time these days. Everybody's so busy. Attending lecture on a daily basis is one of the most efficient things you can do to start this learning cycle or this cognitive cycle. So definitely want to attend lecture. Now, the second thing on the left is reading the textbook or alternate materials. This also helps you construct your mental models. So your previous experience, lecture, and reading the textbook all go in to constructing this mental model of how a particular topic works, okay? Now, once you start to build that mental model by being exposed to these things, and that construction of your mental model, it's almost automatic in your head, based on, just your exposure, your collection of information, essentially. You come up with this model yourself, okay? It's almost free. You just have thoughts in your head, basically. But after you come up with that mental model, you can't stop there. And this is very, very important. Because that mental model that you've developed, it might not be perfect. There might be exceptions to it. There might be times where it breaks down. And if you stop with only constructing your mental model, very likely on an exam, some deficiencies of the model might show up, and you might get a lower grade than you'd hope for. So what I'm going to encourage you to do is, after you construct this mental model, you got to go on in this learning cycle to the next steps. The next step is that you have to test your mental model. You test your mental model. So you develop an understanding, and then perhaps you work some homework problems. Or maybe you go in the lab and you perform an experiment and you test the assumptions of your model. It's testing your understanding of how the chemistry works. And then after you test it, you can assess your mental model. Does the model, as I understand it, work and fit all situations, or are there limitations or exceptions? Maybe the model, as I understand it, is not consistent with reality, and I have to change my model. I have to revise it. And that's that last step. You revise your mental model as needed to tailor it to the situation, okay, that better reflects reality. So over here on the right then, these last three steps, construction of mental model, testing, and assessment, it really forms a cycle. You see that? You make the mental model, you test it, you assess, and you revise the model as needed to make a more accurate reflection of reality. And that's going to be your job as a student, essentially, okay? Now, of course, the work is in the box on the right and the box on the bottom. You don't get this testing and assessment for free. You got to put in a little bit of work to be able to do this, okay? And that's why you have to come up with evaluation of your cognition, okay? Because once you form thoughts, you're going to have to start to test them and assess them. It's going to take a little bit of work. You're going to have to work some homework problems, or perhaps you have to do some experiments. But that's what's necessary to complete this cognitive cycle. And the more times you go through this cycle, the better your mental model will end up being. All right, so now that we talked about the importance and really the necessity of checking your mental models after they're formed for correctness and accuracy in this iterative process, what can actually be done practically to test these mental models that I have of how chemistry works? Well, there's a couple things that you can do, all right? One, you can read the textbook chapters to see if you come across any information that's inconsistent with your model. And beyond just reading the textbook chapters, maybe talk with other people. I mean, really any other information gathering, as long as that information is correct, can serve to modify your mental models. Now, in terms of other things that you can do to test your mental models, probably the biggest suggestion that I have for you is working as many sample problems from the book, the end of chapter questions at the end of the chapters, and the assigned homework. This is absolutely crucial to your success, okay? Because the problems that you face on the exam are oftentimes very similar to the types of problems that you see in textbooks. They're written in the same style by similar people. So it's really great practice for the exams. And not only that, by working these end of chapter problems, you're basically testing your mental models of how that particular concept works. And by checking your answers for correctness, oftentimes the answers at the end of the textbook, or very end of the textbook, I think the odd numbers, usually it's the odd numbers, they give the answers, okay? You can check your answers for correctness. And if your answer is incorrect, you can work to understand why it was you got the wrong answer. In doing this, you teach yourself while your original mental model was not accurate, and you're able to understand what needs to be revised to make it more accurate. Is this just an exception, or is this something that I really don't understand, okay? So again, I cannot stress enough that working the sample problems at the end of the chapter is really, really important for testing your mental models. Okay, it's probably the most important thing that you can do to help assure your success. If you stop at just building the mental models and you don't test your mental models and you don't assess their validity, you're really not completing the learning cycle. And that's going to be really dangerous for you, okay? And the reason why is because you may have some deficiencies that you don't realize in your mental model. And then when you go take the exam, that's going to show up. You're not going to get as high a score as you intended. So definitely take the time to work those end of chapter questions. You know, those end of chapter questions are really wonderful things because your instructor is not going to know whether you got the correct or incorrect answer. There's no judgment. The only thing that those end of chapter questions are good for is allowing you to evaluate where you are at in terms of the correctness of your mental models and your preparation for the exam. Okay, so take advantage of that. Okay, so I hope I've impressed upon you now the importance of working as many homework problems as possible to test your mental models of how the chemistry works. The next question I think that students might have is, well, I understand that working the homework problems is important, but when should I be doing this? Or how often should I be doing this, okay? And my answer to that is more or less continuously throughout the semester, okay? On a daily basis, essentially. You do not want to wait until it's too late. You need to keep on top of things, all right? That will keep you engaged and basically make your workload more manageable than it would otherwise be, okay? So when should you be testing your mental models? Essentially on a daily basis, right? And I pose this question to you to show the validity of this, okay? If you're a student, would you like to rely on your examination grade as feedback to whether your mental models are accurate? Now, to me, I would be deathly afraid of this. No way would I want my exam grade as feedback and my first feedback for whether my mental models are accurate. And the reason for this is exam grades are a huge portion of your letter grade in this class. Exam grades are far too valuable to use them as casual feedback. So instead, use those end of chapter homework problems or the online homework problems as a metric for where you stand with your mental model, as a way to evaluate your mental model. When you show up to take your exam, your mental model should already be well established and refined and perfected to the largest extent that you can possibly achieve. That way, you can show off what you know and get the highest grade possible. Of course, don't rely on exams to provide you with your first feedback. That's a recipe for disaster, in my opinion, okay? Again, these homework problems at the end of the chapters, your instructor's not going to know whether you do them or not, whether you get them correct or incorrect. There's no judgment there. So these homework problems are a very low stakes form to check the validity of your mental models. And that's why they're so valuable to you. You can use them as a self-test in advance of the exams to get a feeling for where you're standing with your mental models and your ability to carry out the computations and calculations that are required for the class. Your instructor's not going to know. Maybe the person sitting next to you is not going to know whether you got it right or wrong, so there's not going to be any judgment. It's just a way that you can check your own progress by comparing your answer that you get with that at the end of the book, deciding if it's correct or incorrect, what went well, what went wrong. This allows you to revise your mental models and prepare for the exam, okay? Now, when should this occur? I mentioned it should occur on a daily basis as we proceed through the course. This is also crucial, okay, that you keep up with this. Earlier in this presentation, I mentioned that your lecture component, your 50-minute lecture, meets 3 times a week. During that 50 minutes, you're going to be presented with a tremendous amount of information. It's information that may have been collected over tens of years, maybe even hundreds of years in certain cases, okay? So it took a long time to build that story. It's usually a tremendous amount of information that's presented to you in a very short period of time. You need to keep up with the processing of that information. And you only process the information when you check the validity of your mental models. So you really have to keep up with assessing the validity of these mental models for each individual topic as it's presented. So basically what that means is if you have a lecture, say 10 o'clock in the morning, maybe it's 10 to 11, sometime that afternoon or that evening, you probably want to devote some time to going over that lecture material, thinking about it, reflecting upon it, maybe reading the chapter on that topic that was considered, and then trying some sample problems from the book on that topic in the hopes that you can assess your mental models and learn as you go, revise your thinking as you go. What you do not want to do is blow this off and wait until a day or two before the exam, because you will be in really, really bad shape if you do that. Okay? Oftentimes students want to do that. It's their time management. But it's not a very effective way to study. If you do that, you will become so overwhelmed in that 2 or 3 day period that you're just not going to have enough time and mental capacity to sort through all of the material that you've been presented with over a period of a month. You're not going to be able to think about it in a very clear way, and you certainly won't have time to better understand all of your mental models, okay, and assess their validity. So it's really, really important that you're working these end-of-chapter problems on a daily basis. So to summarize this presentation, I think it's safe to say that both the student and the instructor have some roles that they can play to help assure common success. On the right, the instructor's job is really to help the students build rough drafts of mental models through lecturing and exposure to the textbook. Instructors will also provide opportunities for some feedback on the model suitability that the students develop, and this is usually done through assigning homework assignments. So when we give you those online homework assignments or in-class polls, that's really what we're looking to do, is giving you a formal way to get some feedback before the exam so that you know where you stand. Now, I kind of want to caution you against working with friends to complete the homework or getting answers online if they're available. In some cases in the past they had been. If you're doing that just for the grade, you're circumventing the learning process. You're circumventing the affective feedback business, okay? You're not thinking at all about your mental model. You're just trying to enter information to get points. And that is in no way effective learning, right? And that's why we consider that business academically dishonest, okay? And you're also really shortchanging yourself because you're not getting that feedback that you need. You're going to falsely think you're prepared for the exam when in fact maybe you are not prepared for the exam. So that's something to think about. Our last task as an instructor is to assess your mastery of the topic through giving exams and the assignments of grades. Things that instructors cannot do. Unfortunately, we can't really motivate you to participate in this learning cycle. It's something that's intrinsic and unique to each individual student. The student in their own mind needs to decide that the information is valuable for whatever reason, and those reasons vary, but that needs to be done. And then you need to have the discipline to go through this learning cycle, to build the mental models, to assess them, and go through that feedback loop as many times as you need until you have a very, very good mental model built and you're ready to take that exam, okay? So because of that, because we can't motivate you, we really can't assure that all students will excel. We can just try to give you the tools to assist you to perform yourself, basically, because ultimately it's really up to you to complete this cycle and do well. And that's really what the spirit of this video is, to kind of give you some pointers, okay? Now, what is a student's role? Students should definitely attend a lecture on a daily basis and be engaged in the class. This is going to aid in forming mental models very, very quickly and efficiently. You have to have that mental model. That's the first step. And fortunately, it's usually very, very easy and straightforward to form a mental model. It's almost automatic once you value the information, okay? Lecture is a great format for quickly and efficiently building these mental models because your instructor basically gives you a rough draft of what that mental model should look like. Then you have to go to the hard work, okay? You have to test it and assess the mental model that you have. You usually do that through homework problems. Working the sample problems in the book is a great way to test your mental model. And you need to repeat and that cycle over and over and over as many times as you need to master the content well in advance of the exam. So on exam night, you can really shine and get that grade that you really, really want, okay? Again, students will need to test your mental models on a daily basis to keep up. A tremendous amount of information will be presented to you. You need to keep up with that, okay? Do not wait until a few days before the exam. You will be completely overwhelmed and it will be very, very difficult to do well on the exam as a result, okay? Lecture presents information very rapidly, so you need to be testing your mental model built on that information as rapidly. You need to keep up with the baud rate, so to speak, or the information that you're being fed. Very, very important. With that said, I hope this video is useful to you. If you have any questions to clarify, please let me know.